Welcome to a lesson with Dr. Powell. Let's take a look for a minute at some non-examples of the mean value theorem, meaning times when maybe the hypothesis isn't satisfied and what might happen. Let's look at this case. Why is not the hypothesis satisfied? That's because the derivative does not exist here. There's no tangent line available here. If you zoom in on this point close enough on the function, you won't see a straight line. You'll always see a corner, no matter how close you move in. And so there's no tangent line right here. Now notice, if this is a straight line that way and that way, think about the slope of the secant line right here. It appears nowhere here as a tangent line. Hence, the mean value theorem basically can't be applied. So notice that there's a condition to the mean value theorem that must be satisfied in order for the result of the state to actually hold. So first you need to satisfy the condition so that the result of the theorem holds. Oftentimes a theorem has a condition and a result. The initial condition must be satisfied in order for the result to be satisfied. A condition of a theorem is often called a hypothesis. This is in contrast to, like, in science with a scientific method or something like that. No, hypothesis does not mean the same thing here. It simply means the condition. If the hypothesis is satisfied, that means the condition is satisfied in a theorem. So for a theorem, we often say satisfy the hypotheses, and then if they're satisfied, you have the result. Where hypothesis simply means the condition. Let's look at this particular case. Now, right here, that's a point where we don't have a tangent line. But still, notice that we get some things still working. Notice if we take our interval from here to here, there, if this is like a zero slope and that's like up to like a negative infinity slope, and this secant line has a negative slope, it definitely is hit somewhere over here. In fact, maybe just way down here, you might get something. If it goes down here to 0, it might be hit somewhere in here. So it is possible for the mean value theorem, it is possible for the result to still be satisfied, even if the condition is not satisfied. However, there's no guarantee. This theorem, it was only developed under the strict idea that these conditions were satisfied in order to deduce the result, although it does happen occasionally where results can happen, but the condition wasn't satisfied. We're just looking for a guarantee. But notice that if we had like chosen an interval like from here to here, that wouldn't work. There's no zero slope in the middle here. So what about this case? Well, the secant line has to be drawn between the 2 points of the function right here and here. Notice this has a negative slope, this has a positive slope, just a little tiny bit of a negative slope there, but it's not very steep and it's not going to be this steep. So we notice that the condition was not satisfied, therefore we have no guarantee of the result. Remembering that the mean value theorem basically says that the tangent line will be parallel to the secant line at some point in the interval. Thanks for watching.